Okay, here we are. We're going to name some amines. Not much new here. As you might guess, 1, 4, 6, 8, 10, 11, undeck, and, okay, and what's on carbon 4? What functional group? Amine. That's how it shows up in the name. Undecan 4 amine with a little stereo center that happens to be S. Pretty good. Now, does that heterocycle look familiar? And I'll remind you, heterocycles, you got to number this way because they're heterocycle. Number 1 is the heteroatom. And if there were double bonds in an aromatic ring there, you would say pyridine, right? Stop.
No, I found it down on the side, but careful.
Yeah. I had a phone emergency. I was being disruptive in my office area. And my jazz music took over when I wasn't even there. Anyway, so there's an ethyl group on 2. 2-ethyl. Anybody know the name of the heterocycle? It's got pyridine sort of in its name. Pyrimidine's got the 2 nitrogens. Remember that one? Yeah. You forgot because you only saw it for 10 seconds. 2-ethyl pyridine. And that stereo center is R. No, it's S again. And it's got a historical reason that I put this thing here. It's also called S-conaine. It's found in hemlock. Have you ever heard of hemlock? That's good. We're in less barbaric times when less people know about hemlock. Hemlock was a poison, and they gave a philosopher a choice of imbibing this poison to die. He was given a death sentence, by the way, or whatever barbaric other technique they chose to offer that I don't know at this time. Do you know who this Greek philosopher was? Socrates. And he chose the hemlock. Not a nice way to go, but yes, this lecture just got morbid, I'm sorry. And the next one, we've got to figure out what the longest organic piece is, because that's the parent. And are you surprised by anything so far? That's the longest organic portion. So it's a pent 2 or 3-ene amine. Pent 3-en 1 amine. And how do you tell me there's groups on the nitrogen? We know this already. It's not new. The N, that's right. And I think ethyl goes before propyl, right? Alphabetical. So we're talking N-ethyl. I think I'll put it up here and swing it down. N-ethyl, N-propyl. Uh-oh. It fit. And no stereo center, except there's some double bond geometry, and that's an E, right? After I'm finished 1, 2, 3, 4, 5 here, I will do part A. I know some of you are saying, when is he going to do part A? You got to have the pictures before you can do part A. Now, an aromatic amine with 2 nitrogens, those are the 2 that are found in DNA, right? Well, sorry, aromatic amines found in DNA and RNA are of the variety of pyrimidine, which is this family here. Or when there's 2 rings, What's the other one? It's very nearby. Purine and wait a minute. I was looking ahead too far, obviously. This is the pyrimidine on the left. And the purine, since we brought it up, will have the same rings. And there it is. But fused here is another ring. And I don't want to mess this up. So I'm going to go off screen for 10 seconds and get my useful information here. You're seeing it in the room here, but they can't see it on the video. I've drawn this part already. I just needed to know the NH is right by the bicyclo bridge. And that's all I needed to know to finish this off. NH is right near the bicyclo bridge. Double N on top. Right there. And that was too many carbons because a little glitch on there. Hey. Sorry. Hello. There we go. It's a 5 fused to a 6. And there's purine. And I will share with people where I got this information at this time. And I'm going to stop the share here. I'm going to go share with the Word, which is right here. I just stole this. I'll make this available to everybody. I stole it from this website. And it's a good review of numbering system. We're eventually going to be drawing DNA and RNA very soon. Next test. Okay. So keep in mind that there's this ring system here that's a sugar-based ring system based on furan. And the bases are these nitrogens here and here, and here and here that get attached over here. We'll talk about these things later when we need them. But I need the numbering system for purine here. Remember, number 1 has to be a nitrogen. It looks like they chose the bigger ring for that. And I think they wanted to keep the numbers as low as possible, is why they chose it here instead of going the other direction. And I'm just trying to, if there's some logic to a system that you have to learn, then it's going to help you learn the system, right? So you go towards the little guy from the big guy, 1, 2, 3. So you can remember that, 1, 2, 3 towards the NH there. So we're coming back to our exercise that we're doing. Don't do the end. Almost did. Okay, so we're here. Was this not the 1 over here? And the 3, 4, 5, 6, 7. I didn't miss anything, did I? No. And we need on 8. Where's 8? I picked a molecule that is a unicorn because I was just coming up with the activity without thinking of the picture in my brain. I got to change that 8 to maybe a 9 just to make it doable. If you put a bond on 8, I give you an OV, right? He gives me a question on the test. I answered the way I'm supposed to, and I get a -1. That's nasty. So let's not do that. Let's make it 9. Fix it up here too. 9. There we go. And iodo. I'm the only one he didn't number here. 9. Yeah, makes sense. 6 and then 3 is 9. Good. And we're moving back to pyrimidine. There's a group on what position of pyrimidine here? And what's the group? Oh, it's not 1. It's 4. 4 isopropyl pyrimidine. And then we got this crazy bicyclo here. We're sneaking in some new stuff here. I don't think we've seen this before unless you look carefully at some old test 2 practice exam. Remember, that was your favorite nomenclature of the semester. He said most sarcastically. because that was the 30-point one you just got back. And some of you liked it, did okay, which is cool. There was a hint on some older practice exams that when you have a heteroatom taking the place of a carbon, you can actually just name the molecule as if the heteroatom isn't there, and then use the word, in nitrogen's case, aza, A-Z-A, and just give it a number where it belongs in the ring. And it's treated like a carbon, but when you said aza, you said, by the way, it's not a carbon, it's a nitrogen. Okay, so we're going to do that for that one. The other one's just a regular old amine. Okay, so let's use the numbering system that would give us the best numbers, and I think you agree that would do it. And you're saying, but wait, Dr. Whitaker, oh, that's not that. You did not go number one with the heteroatom. You'd be right. That's not an 8. That's a 7, right? Okay. When you're going to use the aza or the oxo system, what the heck is oxo? You can call this tetrahydrofuran. It's one you have to know anyway. Very common solvent, so common it has a short form. You can call it oxocyclopentane. This is the same as aza, which we're about to do in the example number 5. Oxo means oxygen took the place of carbon in cyclopentane. Pretty self-explanatory, right? Okay. Oxocyclopentane. So this will be, whoa, N, wow, NN, 3, N, 3. Whoa, try what? This is one of my favorite tricks, right? It's not a trick. Draw it out with this form and then see if they recognize that's the same thing. I do it all the time, like every test almost, right? So why did they get a 3 here? Why is there a 3 there instead of an N? Good question. No, I didn't ask why I put try here. I asked, why is there a 3 here instead of another N when the isopropyl is attached to N? Because I'm using the aza system, and then that's just a carbon number, the 3. Treat it like it's not a nitrogen. I mean, you got to tell me it's not a nitrogen. That's what the aza is for. It's coming up. But NN3 triisopropyl are the groups on this molecule, isopropyl. And it's a bicyclo, and aza should go first. 3 aza, bicyclo, and I believe that's a 4. Ooh, 4. 2. So, dex, and where's the amine? The one that's not an aza. There's an amine sticking off of the ring. Where? 1. Amine. And stereo center. This is long. Didn't know it'd be that long. The 1 stereo center. Oh, he was not very nice to us. Oh, he was. The wedge is the number 4. So you're going to go 1, 2, 3. It's not R, therefore S. And the 6, also straightforward, I believe. The 5 would be the one. So it's going like this. And that's also S. 1, 2, 3. Didn't put the numbers down. Okay.
So what is the number 1 through 6 and in ring and 5? But in, the other one was a purine.
Ah, okay. So the purine, where's the purine? Over here. Oh, why in this system did we not start at the bridgehead?
Yeah.
That is the accepted numbering system for purine. It's got its own rules. Forget about all your bicycle rules. They redid the game. I know it's frustrating because they were not consistent. So if they've given it a common name, often they've got their own numbering system for that common name. Pyrimidine, it's not a bicycle, so the issue doesn't exist, right? But purine is a bicyclo, but it doesn't follow bicyclo rules. It follows the purine rules, which is brand new to you. So I think I'm going to sneak off screen the that other document from that website down on the bottom of this. Okay, try not to forget that.
But in the numbering system, the numbering goes up, like it's 1, 2, 3, 4, and then the 5 is instead of the 8.
Yeah, it's its own numbering system that you have to learn. Yeah. Okay. And where are we going to go next? We're going to do REN homo allele. Homo, oh man, he's making it mandatory. We have to know what homo means now. You remember what homo means? If you have an allele, how do you make it into a homo allele? Where it was attached, you got to break it off and sneak an extra CH2. That's it. Okay? So I'm going to draw allele, but with an extra CH2 to start it. There'll be 2 CH2s, then the vinyl, if you want to look at it that. And that's going to go on non-2-ene-7-ine-4 amine. Wow. That's a straight up 9 carbons. 2, 4, 6, 8, 9. No, that's 10. Okay, there's 9. And we want an ene on 2. And I want an ine on 7. 7, 8, 9, right? 9. It's got to be 7, 8. Ouch. And 4 amine. Got an amine on 4. It's got an H on 4 too. And N. Don't forget the H on the N. And the homo allele. So purple. CH2 once, CH2 twice, C double C. CH2 once, CH2 twice. There you go. And it's E. That worked out nice. What about the stereo center? Currently, it would be S. So how do I fix that? If I connect 1, 2, and 3 right now, it's S. And you don't have a wedge and a dash, so you're not going to get any points for your stereo center. Yeah, 4 on the wedge and nitrogen on the dash, and you are home free. We still haven't categorized any of our nitrogens. Maybe I'll finish all of them. Do part A later. Parole. Who remembers parole? Parole. How big's the ring? How many atoms are in the ring? I remember parole and furan together. Parole's the nitrogen version. Furan's the oxygen version. And furan's easy to remember. In fact, I want you to learn this now. Furan 5. Now, ring sizes in nature. Furan's part of a lot of rings in nature, and so is parole. Okay? The ring size is 5. Ring size 4, not very common in nature, right? That's your first guess. Those are weird ones. They exist, but they're weird. Okay? So, parole has 5 atoms. Nitrogen's one of them, and it's aromatic. So there's parole. And it's got the single ring with a heteroatom, so you know the rules about that. Heteroatom is number 1. And carbon 2, and then 3. We'll go here. How do you draw a methoxy? Don't draw CH3. CH3 with an O. That's right. Methoxy. And this guy, we don't have enough room. Non-menoic acid. Non-menoic. So there's a oic acid right there. That's 1, 2, 3. 3 has a double bond. On carbon 4, we also have a group, and I better put it down here. And then 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. What else is on the nitrogen? Should be 2 things on the nitrogen. There's an ethyl. That's the obvious one. What's the not so obvious one? But there has been a student in this class already lose points for not putting hydrogen on nitrogen. Not allowed. You gotta put the hydrogen on there if it's there. So don't forget, you need to put hydrogens on nitrogen if they're there. Did we finish? We did the Z. We got the N. We don't have the. Yeah, we have the N-ethylamino now. So we learned a new way of doing nitrogen when it's combined with a more important functional group. You call the nitrogen a group. What kind of a group? An amino group. It's not a hard group name, is it? Yeah. You can't put an amine at the end of this name. That's why we had to do this. And when there's a group on the nitrogen, that's not a surprise. I think we got that molecule. Stretch out our arrow here. Okay. And aza bicyclo 3,2,1 octane. Go with purple. So do your 3,2,1, right? You got your dot. You got your dot. You got your 3, 2, 3. You got your 2, 1, 2. You got your 1. You decide where carbon number 1 is. It's normal bicyclo rules now. And what are you going to do to that dot? Make it an N. I like that N. There's an N there with 3 bonds. Yeah, we've seen that. I don't think there's anything else special here. That's it. I think we're finally ready for part A. Part A says for the aliphatic amines. And what the heck is aliphatic? I don't use that word much. It's lacking in my teaching because it is a popular word from the past that's still used by most chemists. And I just don't do it. That and the word olefin. I'm just not big on them. I don't know why. I'll bring up olefin in a second. Aliphatic means the carbons attached to nitrogen are all saturated. They're fatty, like fatty acids. This predates this sad period in human colloquialism, I will say, where there was an expression out there, and I'm not going to explain what it is, but it was, hey man, that's fat. And it was PHAT. It was a thing before this generation. You guys are much cooler. And I won't tell you what PHAT stands for. But it's replacing fat, right? FAT. Organic chemistry did it way before then. Okay? So fat replaces fat. Got it? And hey, the 1 carbon attached to nitrogen here is sp3, right? What's the category of nitrogen when there's only 1 carbon attached? Yeah, primary, 1 degree. What's the category of nitrogen in conaine here? Secondary. What about nitrogen with 3 bonds to sp3 carbon? Tertiary. Next one we're not going to do. You know why? It's not aliphatic. These are sp2 carbons attached. We don't categorize. Now we categorize both of these the same. Tertiary and tertiary. That's a terrible looking tertiary. Tertiary? Tertiary. And the next one is also tertiary. This right there, 1, 2, no, it's not tertiary. Doctor, whatever. Secondary. Next one we don't do because it's attached to sp2 carbons. And then the next one we don't do either. What's the category for 3? It's not primary, secondary, tertiary. If you had to give it a category, just call it secondary enamine. Oh, that one we do have a category for. Secondary enamine. It's not an amine, it's an enamine. Don't do the purine. But our aza, we can do that one. That's tertiary. There you go. Good stuff. There's a double activity if I ever saw one.